as far as velocity versus volumetric flow. And it's based upon, on a sized pipe, you have so many gallons volume on a pipe, and the speed it goes through times the cross-sectional area basically gives you an amount of liquid. To put it in perspective for how this works, if I have a long pipe here, inside, and this volume represents 3 gallons. Say this distance is 6 feet. And in 1 second time, this liquid all moves past this point. If that's the case, then the velocity would be 6 feet per second. You see that? The volume would be 3 gallons per second, or 180 gallons per minute. Now, if the pipe's twice the cross-sectional area, it would be 6 gallons. So for the same velocity, we'd have twice the volume. If the pipe was shrunk so that the cross-sectional area was half, we would have half the volume as far as flow rate for the same velocity. Velocity matters in one direction. You can see what really happens here is we have a cross-sectional area times what length of liquid moves past this point every so many time units. So velocity measures the length, but the cross-sectional area is multiplied times to get a volume. Remember, volume is really the three-dimensional. Length, width, height. Or we want to think in terms of pipe, more like a cylindrical coordinate system. You get down to it. Length, radius, and angle. The angle, of course, being 360 degrees. Now it gets down to moving stuff in pipe. It's almost always round. And what are the two reasons for having a round pipe versus square pipe or rectangular pipe? Or some other shape of pipe?
The friction for the corners.
Friction is part of it. The circle has the lowest amount of surface area per cross-sectional area. It's the shape of the lowest circumference. Squares, for the same length of circumference, less area. Ovals, less area. Rectangles, less area. Triangles, less area. The circle is the most efficient shape as far as cross-sectional area versus circumference. That's handy from a couple things. One, less surface area, less friction. So, Brandon was correct. It is less friction. Other part about it is less material. A circular pipe is going to be lighter than a rectangular pipe for the same amount of volume moved. Less metal involved. It's also uniformly stronger. There's no one weak point in a circular pipe. If you have a square corner, the corners versus the sides are going to be different. One will be stronger than the other. It's not necessarily that the corner or the side will be the weakest. Depends on how it's constructed. but there is somewhat of a difference. There's also a difference in flow. Now, any sort of difference in flow is going to create what's called turbulent flow versus linear flow. Hydraulics, pneumatics class. I don't know if you have that. Turbulent flow versus linear flow. Linear flow is what you want. Turbulent flow fights against your flow. Turbulence means stuff goes around in a circle in the pipe, back and forth. Turbulence. It doesn't really move material. Linear flow does. You want to try to minimize the turbulent flow because it really just fights against things. That's where the velocity versus volume comes in. Kind of relationship. It is different. The bigger the pipe, the higher the volume movement per velocity. Now, of course, the other thing this leads to is something called a Venturi effect. Is that if we narrow this pipe down, we're not going to go through numbers because it's not really a material thing. But if we go down in pipe size and back up, and let's say this cross-sectional area here is 1/4 of this cross-sectional area. 1/4. Given this 6 foot and 3 gallons, so we get this velocity of 6 feet per second here, and 180 gallons per minute on this area. I'm going to ask the question of, what's the volumetric flow rate here? The volumetric is still going to be 180 gallons per minute. Okay, if you have a gallon flowing in here and a gallon flowing out, what has to flow through? A gallon. So we'll always have the same volumetric flow rate no matter what. What does change here? Velocity. Because you have 1/4 the cross-sectional area, you're going to have 4 times the velocity to make up the difference. So when you have narrower areas, you get higher movement.